Welcome to ANMAC KSSM channel. This is KSSM at Max Form 5 exercise discussion. I'm Madam Wong here. Exercise 8.1. Number 1. A particle moves along a straight line and passes through a fixed point O. Its displacement, as Mr., is given by s equals to 2t squared minus 5t minus 3, where t is the time in seconds after the movement begins. A. Find the instantaneous displacement in meter of the particle when number 1, t equals to 0, number 2, t equals to 2. So, A, we need to find the displacement when t equals to 0. So, use the function s equals to 2t squared minus 5t minus 3 and substitute t equals to 0. There we get s equals to 2 times 0 squared minus 5 times 0 minus 3, and we get s equals to negative 3 meter. Number 2, when t equals to 2. So when t equals to 2, s equals to 2 times of 2 square minus 5 times of 2 minus 3, and we get negative 5 meter. B, number 1. B, find the time when the particle, number 1, passes through point 0. Number 2 is 9 meter to the right of point 0. Number 1, pass through point 0, which is s equals to 0. So when s equals to 0, 0 equals to 2t squared minus 5t minus 3. Then we can factorize the 2t squared minus 5t minus 3 with 2t plus 1 and t plus 3. There we get t equals to negative 1 over 2 or t equals to 3. And t is about time. So t must be greater than 0, therefore t equals to 3. Number 2, s equals to 9 because 9 meter to the right of point 0. Point O. So 9 will be positive. 9 equals to 2t squared minus 5t minus 3. And then make this quadratic equation in general form. We get 0 equals to 2t squared minus 5t minus 12. And factorize the 2t squared minus 5t minus 12. We get 0 equals to 2t plus 3 and t plus 4. There we get t equals to negative 3 over 2 or t equals to 4. Again, t is time, so it must be greater than 0. It must be positive. Therefore, t equals to 4. C. Determine the range of time in seconds when the particle is to the right of point O. So we are talking about range of time. Therefore, when the particle is on the right of point O, s must be greater than 0, and we get 2t squared minus 5t minus 3 greater than 0, and 2t minus, we factorize the 2t squared minus 5t minus 3 in 2t plus 1 and t plus 3 greater than 0. So from the quadratic curve, we have negative 1 over 2 and 3 as the root, and when we want greater than 0, so we want the part that above the t-axis. Therefore, t is less than negative 1 over 2 or t is greater than 3. But as we see, t must be positive, therefore t must be greater than 3 seconds. Number 2. A particle moves along a straight line and passes through a fixed point O. Its velocity v meter per second is given by v equals to t squared minus 8t plus 7, where t is the time in seconds after passing through O. A. Find the instantaneous velocity in meter per second of the particle when t equals to 3. So when t equals to 3, the v equals to 3 squared minus 8 times of 3 plus 7, and we get negative 8 meter per second. B. Calculate the value of t when the particle stops instantaneously. So when the particle stops instantaneously, the v equals to 0. Okay, there has no velocity. So when v equals to 0, 0 equals to t squared minus 8t plus 7. Factorize this, we get 0 equals to t minus 1, t minus 7. And t equals to 1 or t equals to 7. So since both of these two values are positive, therefore we accept t equals to 1 or t equals to 7. C. Determine the range of values of t in seconds when the particle moves to the left. So when the particle moves to the left, the velocity will be less than 0. So when the velocity less than 0, t squared minus 8t plus 7 less than 0. So factorize the t squared minus 8t plus 7 into t minus 1, t minus 7 less than 0. There we get t equals to 1 and t equals to 7 on the t-axis. And with the quadratic function, we want lower than t-axis. Therefore, our t is between 1 and 7. Number 3. A particle moves along a straight line and passes through a fixed point O. Its acceleration a meter per second square is given by a equals to 8 minus 4t, where t is the time in seconds after passing through O. A. Find the instantaneous acceleration in meter per second square of the particle when t equals to 4. So, a is given as 8 minus 4t. When t equals to 4, a equals to 8 minus 4 times of 4, where we get negative 8 meter per second square. B. Calculate the time in seconds when the velocity of the particle is maximum. When the velocity of the particle is maximum, it happens a equals to 0. We have no acceleration when the velocity is maximum. So when a equals to 0, 0 equals to 8 minus 40. So 40 equals to 8 and t equals to 2 seconds. C. Determine the range of time in seconds when the velocity of the particle is increasing. When the velocity of the particle is increasing, means we are speeding up, we are accelerating. So basically, this tells us a greater than 0. So 8 minus 40 greater than 0, 8 greater than 40, and t less than 2. Thank you.